In the last video, we solved a classic optimization problem involving two posts and the shortest possible rope connecting them while touching the ground between the posts. We explored two different approaches. The first using calculus and a chain rule, and the second using a geometry reflection trick that turns the entire problem into a simple right triangle. In today's video, we're using a graphing calculator to solve the same problem. In fact, the calculator method mirrors how numerical optimization is often done in applied mathematics, where you sample data, you fit a model, then you estimate things like maximum and minimum values numerically. Looking at the drawing, we're letting x represent the distance from the first post to the point of ground contact, and 10 minus x represent the distance from the point of ground contact to the second post. This creates two right triangles. The hypotenuse for the first triangle, using the Pythagorean theorem, will be the square root of x squared plus 6 squared. And the hypotenuse for the second triangle will be the square root of 10 minus x squared plus x squared. We will be using the stat table on the TI-84 graphing calculator. We're going to assign L1 the values of x from 0 to 10. L2 will be the hypotenuse of the first triangle. L3 will be the hypotenuse of the second triangle. And L4 will be the sum of L2 and L3, which will represent the length of the rope. Let's get our graphing calculator set up. First thing let's do is make sure that my y equals table is clear. Okay. Next, let's go to second y equals and look at our stat plot. I want to make sure all the plots are off. I'm going to turn on plot 1. I want it on. My y list, I want my y list to be L4. So I'm going to hit second and 4. That makes it L4. And let's make a smaller block. Let's try that block there. And I want to try maybe red. Okay, so we'll close out of this. Okay, press your stat key, edit. We'll start keying in our information. So for my L1, I want my values of x from 0 to 10. I'm going to put my cursor on L1. And I'm going to go to list here. So I'm going to go second list, ops, and I want to do a sequential number 5. Start at 0, end at 10 with a step of 0.1. So the x that you want to enter is this x here. And we'll paste it. And that will give us the values of x starting at 0 and going 0.1 each time all the way to 10. So it's much faster to enter it that way than to do it by hand. Okay, let's go to L2. Put your cursor on the L2. Go second square root. Okay, in our first screen we said it would be the square root of x squared plus 6 squared. Well, L1 is going to represent my x, so I want to go second L1 squared plus 6 squared. Then press enter, and it should populate that column with that equation. Going to L3, I need to enter the hypotenuse for the second triangle, so I'm going to go square root, open parentheses. It was 10 minus x, so we're going to use L1 for x squared plus 8 squared. So we have the length of the first hypotenuse, the length of the second hypotenuse. Now let's add the two together. So that would be L2 plus L3. That will give me the length of the rope. Okay, let's look at this graph. So let's hit zoom up here and choose number 9. Okay, so there's a graph of all the points that we had. Next thing we want to do is we want to choose a regression that will create a function for this curve. We can go to Stat, Calc. So to choose the correct regression, I had a sum of 2 square roots. So the sum of 2 square roots then should be a quartic, or number 7 here. Alright, so I'm going to choose my x value as L1, my y value as L4. Okay, I want to store this value instead of just appearing on the screen. So to store this, I'll press the vars key. Okay, I want yvars function, and I'm going to store it as y1. And then we'll tell the calculator to calculate this regression. So I have to press enter a couple times. Okay, now it has it calculated. Now let's press the graph key. Okay, notice that the regression is falling pretty much in the center all the way around, which is showing you a good estimation. So now we're ready to do the math. Okay, so if you press your second key, and up here on L4, it says Calc. So I'm going to second trace, which is Calc. I want the minimum value, which is the third choice. So I'm going to get the minimum, I need to put the cursor on one side and press enter of the minimum that I want to measure. Then I put the cursor on the other side of the curve where I want to measure the minimum. It doesn't matter where, just as long as you're on the other side. All right, so it's going to find the minimum between these two lines. I press enter again. All right, so the value of x is 4.2911905, and the value of y, which is the length of the rope, is 17.20415. Using calculus and the chain rule, we got for the value of x 4.2857 and so on and so forth. And for y, we got 17.20465, so on and so forth. In geometry, using the right triangle method, we got 4.2857 and 17.205. And then using a calculator, which is basically, it's approximating the answers. So x equals 4.2911 and y equals 17.20415. So you can see the calculator is not quite as close as the other two methods, but it's in the ballpark pretty well. So we independently used calculus, geometry, and numerical analysis using a calculator on the same problem. That's pretty much how mathematical exploration looks. A side note, it's very impressive that a small calculator like a TI-84 can do the calculations required to analyze all this data into something which is fairly close to the correct answer. Thank you for watching. If you found this video helpful, please be sure to check out other lessons on this channel. Please leave a comment, like, and subscribe. Thank you for watching.